Okay, Precalculus, we start chapter 5 today. It's on exponential and logarithmic functions. That sounds like a party. A real quick review. I'm going to take these three functions. I'm going to add, subtract, multiply, and divide a couple of functions. We've done it before, so I'm going to go real fast. I'm going to blow right through this. F plus h of x is x squared minus 1 for f of x. And when I add the h of x, it's 3x minus 5. And so I literally just combine like terms. F plus h of x is x squared plus 3x minus 6. Couldn't be much easier than that. When I subtract, please remember you got to distribute this minus sign. So I got h minus f of x. H goes first, so I go 3x minus 5. And then I'm supposed to distribute that minus sign. So everything after it, if it's got a plus or a minus in it, it's got to be in parentheses. So then I go x squared minus 1. And I got to distribute, so I got 3x minus 5 minus x squared plus 1. And so h minus f of x is equal to negative x squared plus 3x minus 4. So there's some adding and subtracting. Hope you guys are keeping up. Stuff you guys have done a few times. F times g of x is going to end up being x squared minus 1. When I multiply, I put stuff in parentheses. Times g of x. That's x over x plus 3. If I'm going to multiply x minus 1 times a fraction, I got to think of it as a fraction. So you just multiply the denominators, x to the third minus x, and you multiply the denominators. Did I just say that wrong? Probably. And so I get x to the third minus x over x plus 3. I should probably have f times g of x out there like I did with these, but hey, I'm just moving on. H over g, so I got, let's see, we've got 3x minus 5, and it's going to be over g of x, which is x over x plus 3. That's called a complex fraction because it's got a fraction in the denominator. How do you divide fractions? You multiply by the reciprocal. So this is the same thing as 3x minus 5 times, I guess you could call it like it's over 1, right? Times x plus 3 over x. And so now I got to multiply these two things together. I had it like as if this was over 1. It was a fraction in the numerator and a fraction in the denominator. That's where that 1 came from. Okay, so I'm going to multiply these together and simplify them at the same time because I'm pretty much out of room on the paper. Put an x in the bottom. 3x times x is 3x squared. Then I will have 3 times 3 is 9x, minus 5x is 4x, and negative 5 times 3 is negative 15. So there we go. I can add, subtract, multiply, and divide functions. I could talk about their domains, but I don't want to. Here's your new thing for today. You find the composition. And I don't know if you've heard of this before. I'm guessing you have heard of this in Algebra 2. But you find the composition of two functions by substituting the expression for one function in for x in the other function. You call it the composite function. Our author calls it the composite function anyway. Notation goes like this. F with a little circle, g of x. F of g of x is the same thing as f with g of x inside the parentheses. So, if you were finding f of 2, you would just put 2 where you have an x. Well, if we're trying to find f of g of x, you literally take this expression and put that in for x, so that x squared becomes the fraction x over x plus 3 squared, and then minus 1. It implies that you should substitute that expression for g of x into the f of x expression. Okay, so for above, find f of h of x. I'm going to write it again, f of h of x. That means I take the h of x expression, 3x minus 5, and I put it in the x for f of x. So go look at f of x, and where you see an x, underneath being squared, I'm going to put all of 3x minus 5. Here we go. That is going right there. So here we go. F of h of x. That's going to be something squared minus 1, right? The f structure is x squared minus 1. Remove the x, replace it with 3x minus 5. That's how you find the composition of functions. Now I should simplify that. It's going to be 3x minus 5 times itself, and then a minus 1 after that. So I'll go down here, and I get 9x squared minus 15x minus another 15x plus 25 and minus 1. So I'm going to put in the bottom here, f of h of x as a composition of two functions is 9x squared minus 30x plus 24. There you go. F of g of x, f of h of x, composition of functions. Next page.